So here's a bit of text off the internet indicating that when you do synthetic division, the binomial that you're dividing by must have degree 1. We cannot use synthetic division to divide by a binomial like x squared plus 1. Now, I don't know, maybe there is a way we can use synthetic division to do this problem. The key is that this denominator, n squared plus 2n plus 1, is a perfect square trinomial. So we could rewrite this as n plus 1, the quantity squared. And maybe we could use synthetic division to divide by one of the n plus 1s, and then use synthetic division to divide by the other n plus 1. That might work. So here's the numerator where I'm dividing this original numerator by one of the n plus 1 factors. So here's the synthetic division. There's the result right here, where these are the coefficients of the residual polynomial, and that's the remainder. So that means that since we divided n to the 4th by n, that this is the coefficient of n cubed. So there's 2n cubed minus 3n squared plus 3n minus 5 with the remainder of 10 over the divisor. And then this n plus 1 here was the other binomial that we still want to divide by. So let's picture dividing this n plus 1 into this 4-term polynomial and then also into this term here. So I've separated it into 2 terms. Here's the n plus 1 divided into that polynomial. Plus, if I divide 10 divided by n plus 1 by another n plus 1, I'll be dividing by n plus 1, the quantity squared. So here's the synthetic division for this first term. And, oh, and by the way, I should have mentioned that this 0 here is because I need a placeholder for n squared. Okay, so there's no n squared, so I need a placeholder of 0. Here, that is not the case for the second in blue. So there's the residual coefficients, and there's the remainder for that second division. So this first term becomes 2n squared minus 5n plus 8 plus a remainder of negative 13 over the n plus 1 that I divided by, the divisor. And then I said, you know, I like to combine these two terms, these two fractions into one. So I need to get a common denominator. So I multiply top and bottom of this minus 13 over n plus 1 by another factor of n plus 1. And then I combine the numerators. So there's your final answer right there. And this is a case where actually long polynomial division might have been easier, but the directions were to use synthetic division. That's how I see to do it. There you go. Hope that helped. And if you have any questions, post a comment.